Hello, everybody. Welcome to today's Hubble Hangout. My name is Tony Darnell, and we have, I think, a really interesting topic today. Now, you guys have been around Hubble Hangouts long enough to know that Hubble has been over our heads for almost 55 years, circling overhead, looking at things, showing us stuff. And today, and this last Sunday was no exception. Hubble looked at something, and it showed us stuff, specifically a comet that passed close by Mars. And today we're going to be talking about that with the old gang of a lot of very familiar faces and a couple of new ones. But before I get to that, I want to make a quick announcement. Today, as I said a while ago, almost 25 years Hubble's been up in space. And you're going to start to see a lot more about this from us. We're going to be talking about it a lot more. But all these events that are going to be coming up for Hubble's 25th anniversary, which will be in April. The first of those things is starting today. So if you are in New York City, the Big Apple, you need to get your little booties over to the Intrepid Museum. And they have opened up a Hubble at 25 exhibit. It opens today, and it's going to be going on at least through April. I know that much because one of the events they have planned, I'm going to be there for. So you've got plenty of time, but get over there today if you have a chance. Go to the website if you want to learn more about it is intrepidmuseum.org. They'll learn about they have tickets available for events and stuff that are coming up. So I would encourage you if you're in the area to check it out. Hubble at 25. That's our new exhibit, and we've posted about it on Facebook and Twitter and stuff like that. And I'm about to do it on G+ after this event, so I'll give you more information as that progresses. Carol and Scott, Dr. Carol Christian and Scott Internet, the driver of the Lewis. Oh wait, I did not say that right, did I? That is not right. Well,
I have a sonic screwdriver.
Scott Internet's a pretty cool name, though. Anyway, Scott Scott Lewis is helping drive the internet in this hangout, as is Dr. Carol Christian. She is the Hubble outreach scientist for the Space Telescope Science Institute. So today we're going to, like I talked about, Hubble on Sunday looked at a rather unusual close flyby of a comet to the planet Mars. It went within 140,000 kilometers, and which is about 80-something thousand miles, I believe, which is really close, really close. And so Hubble went and looked at it, and we took some images. And with us to talk about this today are the various astronomers and people who helped get these images together. Carrie, is it Lissa?
Yes.
Liss, sorry, thank you. From Johns Hopkins, he's an astronomer and comet person. Also, Jianyang Li, you might remember him from the Planetary Science Institute. He was around our hangouts when we were talking about Comet Ison. Hi, Jianyang, welcome back. Also, Max Mutchler of the Institute and Zolt LeVay, also of the Institute, helped us put together all of these images, and so that we're seeing today. And Zolt, do you know you got a fan club? When I told people about this event, we got some comments on Twitter about, oh, Zolt's going to be there, so I have to go. So you got a fan club. You're like famous now. So
hope I can live up to the hype.
I think you can.
Okay, so before we get going too far into the hangout, let me remind you that you can tweet at us using the Twitter with the Hubble hashtag or the Hubble Hangout hashtag. We're also looking at the Q&A app on YouTube and G+, as well as the comment section on both of those pages. So we hope you'll comment, ask questions. All of these guys are here ready to take your comments and questions for you, so we hope you will do it. Yesterday, we talked about this a little bit with Frank, and Frank Summers, and he was telling me that, well, that these images were a little slow in coming, right? I mean, we were a little bit, Hubble looked at the flyby, but because of something called I think it's the SIC, this gets the award for the worst acronym ever. It's called SIC and DP module on Hubble, which I guess is this thing that Hubble does this thing I did not know, where it kind of does this equivalent of a spinning beach ball, where this is a known thing it does, and you just kind of have to wait for it to get done, and
Was that a Mac reference? This
Yeah.
song?
Well, that's the way it was described to me. I guess the Hubble does this every once in a while. And this is an inside, behind-the-scenes look, guys. We got these emails earlier in the week. Hubble's fine now, but apparently it does this thing where it just kind of does a spinning beach ball kind of thing, and just like it's one of those things where if you get it on an Apple computer, it's just you just have to wait for it to finish, and then everything's fine supposedly. So
And on the Windows computer, you get the blue screen of death, and sorry.
And that is a bigger problem, yes. So I guess these images were a little late coming down. Isn't that right, Zolt?
I think maybe Max can answer that a little bit better.
Yeah,
our images that we had came down in good time.
Yeah, they came down over the weekend. There was a sequence that started, I guess, late on Saturday, through Sunday and Monday. That was all before the failure that you mentioned. So those data came down. There was a little problem getting them out of the archive, so we didn't really get to look at them until Monday morning, even though the closest approach had already occurred. That was really the first chance we had to really dive into the data. And then it was, I think, a good day and a half later that there was the real significant, safing or SIC and DH event, which caused a bigger hiccup. So thankfully, most of the data from this campaign was already in hand before that. There was a continuing program by John Clark, one of the investigators involved in this campaign, that was more affected. But fortunately for the bulk of this campaign, the timing was not too bad. It could have been much worse if it had landed right in the middle of our campaign.
Yeah. I guess I wanted to bring that up just a little to kind of give people a little of a behind-the-scenes thing of what it's like to use the Hubble and some of the things the Hubble goes through, and I just learned about that recently, so I thought I'd mention it. It's not a serious thing that happens, but we just have to wait for it to pass, I suppose. So, okay, Jean Yang, let's talk about I'd like to ask you about this flyby. Can you give us an intro into what happened? What went on last weekend?
Well, as you said, basically the comet is coming from far, far away, like the edge of the solar system, and then it happens that it just fly by past Mars from very close distance. The distance is actually only a third of the distance between the Earth and the Moon, so it's very close. Imagine if you have that kind of a comet that fly by the Earth from that distance, that's going to be amazing. But this time it happened on Mars, and basically the comet, we imagine the geometry. The comet basically comes from the bottom, from the south, below the plane that the Mars is orbiting the Sun, and then from the bottom, and it passes. I think it's slightly inside Mars orbit, and then cross Mars orbit plane to above, and then from there it continues to go to its closest point to the Sun, which is very close to Mars too, and then leave the solar system. So what happened last Saturday was the comet fly by to the closest distance of Mars, and that happened, I think, on Eastern time about 2:30 Saturday.
Okay. Now, Carrie, can you give us some idea of what the comet itself was like? Comet Siding Spring. What was it? An amazing comet? Was it a regular old just run-of-the-mill comet? What kind of comet are we talking about here?
It was actually a very little overachiever comet. What we've heard. Well, we saw this comet out by almost the orbit of Saturn, just like we got Comet Ison last year. And what we've learned now, just by the flyby of Mars with the MRO HiRISE, which actually imaged the nucleus, is that this is a very small comet, maybe half a kilometer in radius, a kilometer wide. So there's no way we can ever see a body that. Remember, comets are very dark. They're darker than asphalt. They're darker than coal. There's no way we can see a body that small and that dark out by Saturn. The only way we could is if it was really, really active. It was throwing out a lot of material and gas and dust, even where the local temperature is about 100 degrees Kelvin.
So it's very active then.
And most likely it's very active, just as Yin Yang said. It's been living for 4.5 billion years. The vast majority of the time it's been orbiting the sun, but the vast majority of the time when it's orbiting the sun on a very elongated orbit, it's been way out away from the sun in deep freeze. And it was put together 4.5 billion years ago at the time when we were assembling the planets, and it's a failure. It failed miserably to actually become one of the giant planets. Instead, it had a near miss and got thrown out on this very elongated orbit, possibly even going almost halfway to the next star. So it's never been in this close to the solar system, to the sun before. It's always come in as close as maybe one of the giant planets and gone out again.
And now that it's close, you've called it a failure. I mean,
well,
I'm sure it really
before I called it a failure. It is a failure if it wanted to be part of a giant planet. It's a great success because it's lived a lot longer than its other brothers and sisters. So the reason why it most likely was so hyperactive is it's never been in this close before, and it suddenly had materials that have never been heated so much, and it was boiling off furiously. And that's why we caught it out by Saturn and why we've been watching it all the way in. So it had a very strong ramp up between Saturn and maybe out to the orbit of Jupiter or so. Then it kind of flattened out, and then it actually started dropping just a little bit right before, in terms of its activity, right before it got to Mars.
Okay, let's go ahead and take a look at what Hubble imaged. Zolt, can you do you have any of the images that we put out? There was a press release came out today on our website where we have some of these images now, and I'd like to just kind of take a look at this. Now, Carrie, this is the kind of comet that was on a similar trajectory as Comet Ison was, right? It had one of those really elongated, almost perpendicular to the plane of the solar system, right?
There are a lot of very strong similarities between Ison and Siding Spring in terms of its origin and its orbit, yes.
Okay. So here you go. What are you showing us here, Zolt?
So this is a picture that we put out with the news release today. This shows Mars in the lower center of the image, and the comet up to the above that and to the left a little bit, and then a scattering of stars in the background. Now this is a photo composite, which means it's been put together from 3 separate components. The image of the comet is an actual image from Hubble. This is actually a composite of numerous exposures taken with the Wide Field Camera 3 that have been combined. The comet was very faint, so all these exposures were combined, and that's the image we see of the comet. And then the image of Mars was a separate image also taken with Wide Field Camera 3 in 2 different filters, and these were composited to make the color image. Now these are placed on this star field at the positions where we would have seen them if we could have seen them at the same time, at the time of the closest approach.
So why not just get a picture of all of it in one go?
Well, that would have been really cool, and we were kind of hoping for that. And it turns out that at their closest approach, technically, it would have been possible to have the comet and Mars in the same field of view of the telescope. The camera's field of view, although very small in the sky, is such that they would have fit within that tiny field of view. That's how close they got together in the sky. Unfortunately, there's a lot of technical issues that get in the way. These are both moving targets. These are moving with respect to the stars, and it turns out they were moving perpendicular to each other. John Young mentioned that the comet was coming up from underneath the plane of the planets of the solar system and traveling up through that plane and above it. Well, it turns out that in this view, the comet was coming up from the bottom and traveling through the frame. Meanwhile, Mars was traveling also through the frame in the perpendicular direction, going from right to left through this frame. So if we were to track on the comet to get a good exposure of the comet, Mars would have trailed through the exposure, and vice versa. If we would have tracked on Mars through the exposure, the comet would have trailed. Now the other complication, the bigger complication really, is that the brightness of these things in reality is tremendously different. Mars is a big bright planet reflecting a lot of light from the sun. In reality, at that distance, something like 10,000 times brighter than the comet. As Casey mentioned, the comet is incredibly dark and faint, and even the coma, the material that it's shedding, is not reflecting very much sunlight.
So some of the amateur photographs that came out before this encounter showed that, like, Mars was like vastly overexposed, and then the comet, and it kind of looked like a star, and it had the spikes and everything from the camera, or Mars would be fainter and you could barely see the comet. So it's very hard. And the other thing is that we couldn't get the stars, the comet, and Mars all not moving. You got to point at something, either stars or the comet or Mars. So we did one of each and made the composite.
Everything going in different directions and different rates.
Everything's going in different directions at different times.
Yes.
And I've been referring to it as, in principle, we could have taken that one shot, where they're all in the same frame, but frankly, it would have just been a stunt. You know, it would have been just because we can, because there's really no good scientific reason, or as Oort was explaining, it would not have made nice images that we could have used for analytical purposes. So, you know, obviously we're trying to get the best science out of this campaign and not just pull a stunt like that.
Well,
the
let's
other
talk
thing
about.
I like about this image, if I may just add,
Sure.
is that Mars wasn't terribly big at this time. It was relatively far away from the Earth. So the size of Mars here isn't a bad approximation of how big it is relatively. You've probably all seen the beautiful pictures of Mars when it's, you know, it's on like 20 arc seconds across. That's when it's as close to Earth as possible. At this time, Mars was about 6 arc seconds across, because it was a lot farther away than closest approach.
I want to talk a little bit about the science. And I'll leave this to Jianyang or you, Carrie. What was the science driver for this? What were you hoping to learn?
Go ahead, John Yang.
Sure. Yeah. So this event is actually a very unique event in that you know, this comet is a different category of comets that have been visited by spacecraft from close distance. And we know, you know, like those missions like Deep Impact, like Stardust Next, and all those, you know, like the Rosetta mission that is ongoing now. However, this comet is very, very different from all other comets in that it is this time it's the first time it comes into the inner solar system after like 4.5 billions of years after its formation. So but for this kind of comet, because it only comes into the inner solar system for once and then it's gone, we only have one shot, and also we only have like 1 year after this discovery to its perihelion before it's gone. So that time is very short for us to do any space missions to look at the comet from close by distance. And then these opportunities, in this sense, this opportunity is very unique in that we can look at the comet from a close distance from the spacecraft on Mars. So that is why we're doing it. And then the direct scientific driver for Hubble to look at it during Mars encounter is because Mars spacecraft will be looking at the comet when it's flyby from under Mars orbital plane and then cross it and then go above. So, but then Hubble from the other will look at the comet from another very different perspective. And when you're combining the image from two different perspectives, you will be able to construct the 3D structure of the inner coma of the comet. So basically, that's one driver for these observations. We used Hubble, the tremendous spatial resolution of Hubble. Hubble is can provide us the best images that we can get from all the telescopes on the Earth. So that is one thing. And another thing, I think maybe Casey can tell us how we can study the gas of this comet and interactions with Mars.
Okay.
Okay, let's do that.
All right, I will. Let me just add one thing to what Jin Yang said. All the spacecraft visits to comets we've had so far have been to what we call Jupiter family comets that come from the Kuiper belt, from the edge of the disk of our system. And if you think of the solar system as a record, and the planets move around in the grooves and the sun's at the center, all these comets have pretty much been in the plane of that record of the solar system. These Oort cloud comets come from a different collection or population. The Oort cloud expands basically like a sphere that surrounds our solar system. And it's the farthest, most distant thing we have in the solar system. And we have never been able to get up this close and personal to one before. Our rockets simply, and our spaceships simply don't have enough energy to get to them. So instead, we have to wait until they come to us. So that's another reason this is so special. So now to get to what
blessing of coming to us.
Yeah, it's normally we go to them, but this is a wonderful example of reuse. You've actually used NASA assets to have a free flyby. So Jin Yang wanted me to talk about the other things we want to learn from the flyby. So since the comet was coming to us, we can actually watch it and watch how gas and dust are coming off of it. And we can see if it varies. We can see if that gas and that dust interacted at all with Mars. The largest prediction was that the Martian atmosphere would heat up from gas molecules and tiny little bits of dust hitting the upper atmosphere. There wasn't much material coming from the comet. The mist was close, but not that close. But on the other hand, the comet was moving what we call retrograde. It was actually going backwards compared to the way that all the planets move around, which is counterclockwise. The comet was coming clockwise. So it was almost a head-on collision, almost. And the relative velocity between the comet and Mars is about 56 kilometers per second. It's about 30-some miles per second. So each atom and each piece of dust that would hit Mars's atmosphere brought a really huge amount of energy. So even though there wasn't too much material coming off the comet, again, think of the comet as a very, very small mountain, if that much. It's smaller than the average Appalachian mountain, and shedding a little bit of its stuff, maybe a fraction of a percent. But that stuff can actually hit Mars and Mars' atmosphere, and we were looking to see whether any of that would, again, heat up the atmosphere. Also, the comet was upwind in the solar wind from Mars, so ions streaming off the comet and into the solar wind interacting with the comet would then hit Mars. So we were interested to see whether there was any interaction, any possible aurorae or just kind of puffing up of the Martian ionosphere.
Well, was there any? Did you see any interaction with the atmosphere?
We don't know yet. One of the we had a problem with one of the orbits.
It's Thursday. This happened like over the weekend.
We lost our background measurement. We actually have to get that back real soon. We don't have a measure of what 0 is. There was a problem with the spacecraft. So okay. As soon as that happens, we'll hear more.
Is that Max's job? Is Max going to get that?
Max,
Max, we need a background.
Max went to sleep and the spacecraft had problems. No, the spacecraft is a wonderful instrument, running for now 25 years, you point out. But just like every other machine or robot ever built by man, every now and then it has a hiccup.
Okay.
I'm afraid I won't let you image, Dave.
Yeah, I'm sorry. I can't open the cover. The cover. They don't actually move that anymore. Charles Bell has a good question. Let me ask this one. Before MRO HiRISE, image of comet C2031A1, which is Siding Spring, at close approach. What did you think the size of the comet nucleus was, and what did you base that on?
I think that depends on who you ask. I'll give my opinion, then Xinyang should give his.
Okay. And they should be close, I hope.
Well, the lowest limit we had was somewhere around 0.3, 0.5 kilometers, and that came simply from just seeing how much gas was coming being evolved, the gas production rate we call it, and assuming that all of that was coming from a nucleus. So just imagine a spherical nucleus to make life simple. You can figure out what 4 pi r squared has to be, and because we know how fast water ice boils off at 1.5 AU from the sun, for example. The upper limit came from some of our earlier Hubble observations, and we couldn't say very strenuously what that was. If you wanted to be extremely conservative, it was about 5 kilometers. Most likely, the analysis had shown it couldn't have been bigger than 2 kilometers radius. But we knew almost immediately from the first Hubble observations that it wasn't a ginormous nucleus, because that's the other possibility. You can see it out by Saturn just because it is just big, 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 and we ruled that out pretty fast.
Ginormous, is that a unit?
Ginormous is another technical
term. Yeah, that's a unit, yeah.
I'm actually tweeting that right now, so be prepared.
Yeah. So Zoltan, I don't know if you can show us this or not, but we were talking about the first observations of Hubble. Can we see the progression of Hubble images? Do you happen to have that handy, when some of the first observations back in September versus the ones that were closer, or is that?
Well, let me see if I can bring that up.
Well, I don't mean to throw a wrench in the works if you can't show it. Just curious.
Should have had that queued up, but I didn't.
You're a rock star. I'm sure it'll get it. But let's talk about that a little bit, Xinyang. I accidentally had to mute you and I didn't accidentally. I purposely muted you. But I wanted to. There's an echo. There's an echo there, so I had to.
And then he accidentally slapped you in the face, too.
Now that was you, Scott. Can you tell us a little bit about what happened to the comets from the first Hubble observations, which I think were back in September, correct? What happened to the comet as it got closer to Mars?
Well, I think the most interesting thing, recent change of the comet, was.
Zolt has something up. Thank you, Zolt. Go ahead.
Yeah. Okay. So as you said, Hubble actually the first time Hubble looked at this comet was last year in October, almost a year ago. I can't believe it. But anyway, so since then Hubble observed the comet 2 more times. Once in January this year, another times in.
No, I'm sorry, I had it wrong.
March this year, and from those 3 observations, the comet actually does not change much. But just I think a few weeks ago, there was sign that this comet was this comet had behaved like all the way until a few weeks before the close encounter with Mars. Until that time, we were all very happy that this comet just the performance of the comet, the brightness of the comet, just follows what scientists will predict they are. And then we were all happy about that. But then, like a few weeks ago, people suddenly realized that the brightness of the comet suddenly starting to
compensating
significantly. And and you know, there's no sign about what happened on the comet, and we have no explanation about that yet. So that's what we actually saw in the Hubble images during the close encounter. After the data down, the first thing we check is, of course, whether we have exposed the comet well in our images, whether we have enough signal to work with. And then in the first check, the first thing we noticed was that the comet was indeed fainter than the prediction by like half to 1 magnitude. So our signal is kind of lower than our expectation, but still we have enough signal to work with, we believe. And you know, that's the first thing we noticed in our data, and that's, I think, the biggest change I would say now.
Okay, well, and as Carrie points out, we may still see evidence of some interaction when it flew by, maybe see some aurorae, hopefully. I'll give him till next Tuesday. Hopefully, I'll have something by then at least. Give him the weekend. So Zsolt, now can you sort of show us tell us what we're looking at here? This is the observations back in March.
This is the observations from Mars, and actually maybe John Yang would be better to describe what we're looking at. But what we're looking at on the left is the plane image of basically the raw image of the comet. As you can see, the tail is pointing off to the upper right. It's actually a detectable tail. And on the right is an image process to show the details very close to the nucleus. And I think John Yang can explain why it looks the way it looks.
Well, so what we did was that we we divide the image of the comet by a model that produced a what we call that isotropic dust emission. You know, we assume that, you know, if this comet is emitting all the dust the same way in all directions, then it will look slightly different. And then the image on the right-hand side was the difference between this actual image and that ideal model. So what this means is that the comet is actually emitting some dust preferentially towards the left and also towards the right. There were two features that, you know, we see in a little bit slightly enhanced dust emission in the coma, and this is an indication that the activity on the cometary nucleus is not like the same, not uniform, not the same everywhere. It has some area that is slightly more active than other areas. So that's what we see here on the right-hand side.
Can you call them jets, or is it just some sort of emissions of some kind?
Well, to be precisely, we prefer to call them features.
Oh, features.
Because they're really broad bands, or they could one part could be towards the sun. Yeah, you have to be careful.
Okay. Well, I like the term jets, but I guess that's not precise enough and probably misleading. Here's a question from my cat food.
Hello?
I love that handle. To anybody on the panel, did we know the composition of Siding Spring?
No.
Do we know the composition?
I do. It's space stuff. There you go.
We're all stardust. There you go.
Right.
That's right.
Okay.
I'm going to pull a Sagan and just say it's star stuff.
We knew very roughly that we think it was about half water ice and carbon dioxide and carbon monoxide and methane and ammonia, et cetera, ices, and roughly half rocky stuff, but we didn't know the exact details, and we didn't know how much carbonaceous material there was. We can tell you that ISON seemed to be very abundant in very rich in organics, more than the average comet last year, so we've been looking for that. We don't have any response to that, though, yet.
Okay, so also from my cat food, also to anyone on the panel referring to the SLU coverage, it looked like there either was or wasn't an electrical interaction with the Martian atmosphere. You have any comments on that?
I don't know.
We talked about that.
It looked like it was or wasn't. It
looked like there either was or wasn't.
Was it a quantum show? I'm not sure.
Well, we talked about that briefly already. They don't know yet if there was any interactions with the atmosphere at all. So they're going to find that out and get back to us, I hope. A lot of people look like they're having trouble connecting. So, yes, you're going to need to refresh your browser. Hopefully, in the Hangout will appear to you, but you can't see me say that. So I don't know why I bothered.
I'll post a link to the YouTube into the event page. And
okay. Yeah, seem to be having trouble. All right, so Zsolt, you had created a really nice animated GIF also with the press release. Can we see that?
Yes. Again, that will take me a moment.
Okay, all right.
I will preface it by saying that was a model and an animation. It wasn't based on. Well, it was based on the earlier image of the comet and an earlier image of Mars.
Okay.
They were roughly positioned where I thought they ought to be. So
okay, while you're doing that, let me ask one more question from on the Q&A app. Nastya Kruchanova, sorry if I messed that up. Is it possible to know from which system that comet came from?
Yes. We know the orbit. We've been following this comet for a long time. If I may digress, think of the orbits of the planets like a rubber band. It's almost like a circle. Remember that I talked about grooves on a record?
Mm-hmm.
Your short period comet that we go and fly to with our spacecraft would be if you took that rubber band and you stretched it out a little bit so it kind of looked like an ellipse or an egg. They're not very stretched. The orbits we see for the Oort cloud comets are stretched so long that it looks like almost two straight lines with just little kind of roundy end caps. But if we were to stretch it even farther, so it came from another system, the rubber band would break. We know that the amount of energy this comet has in its orbit is such that it goes around the sun every few million years. It's never been outside of our system.
Okay, so few million years, so you're definitely not going to be seeing this again anytime soon.
Nope, Jin Yang said it. We had our shot at looking at this one. If you're going to be around a few million years from now, maybe, but I wouldn't wait for it. Come back.
I'll wait for it. Singularity's coming.
There you go. Put yourself in that spaceship now and move at the speed of light.
There you go.
Okay, Ray Kurzweil. Okay. Okay, so Zolt, there's Zolt's animation. Go ahead.
There's a little animation we put together, and so you see, as I described before, you can see that the comet's coming up from, and this is looping, so it's just repeating the same sequence of events that's taking place over the space of an hour as this event is taking place. So you can see how quickly these things move. I mean, it's clearly
Mars
sped up for this sped up dramatically, but yeah, Mars is moving from left to right across the bottom, and the comet is moving up from the bottom, and there's a area marked off in green, and that's the area of the sky that the Hubble's camera, the Wide Field Camera 3, can see in one frame. So as you can see, it's all taking place within one frame in principle, although, as we said before, we couldn't actually image them at the same time. So, but that kind of gives you an idea of the scale of what's
and
going on, the time scale, and the orientation, everything. Yeah.
Yeah, that's really neat. Okay, so what's next for these observations, Carrie? Are you going to be obviously poring over the observations you've got? What are your plans for the immediate future with this?
Well, we have a few plans. Part of it is Jin Yang's program. He's concentrating more on the nucleus, and the dust. I'm concentrating more on the gas. It's not that I'm not interested in both, but I have another program which is related. Let me point out one thing that's actually interesting. Jin Yang showed the images from March where it looked like there were two features, possibly jets. But we had, well, the light curve we have, the variation of the comet over time looked absolutely flat. We didn't see any nuclei. The comet nucleus is usually rotating, tumbling, possibly even. And so we'd expect those features to come in and out and get brighter and dimmer. We didn't see any. Now we're seeing hints from at least 3 different spacecraft of a huge amount of variability, but we don't see any obvious jets just in the very quick first look. I mean, we're going to dig deeper. So it's actually counterintuitive. This is a little confusing and exciting.
Oh, okay.
So now let me get back to the gas. I'm also have observing time with the Chandra X-ray telescope, another one of NASA's great observatories. So we were watching both Mars and the Comet, which are both known X-ray objects, and the reason they're X-ray objects is they're immersed in the solar wind. And the solar wind comes along and grabs electrons from their neutral species, and as they de-excite, they give off characteristic X-rays. So we were interested to see whether Mars and the Comet would possibly flare when they came close to each other. And so one of the reasons we were using Hubble was to actually watch the gas coming off the comet and monitoring that, and watching Mars to see whether there were any changes in Mars. And as we've already pointed out, we don't know yet. I can tell you that from Chandra, we have detected Mars in the X-ray. We don't know if it's changed at all due to the comet's passage. We're still working on the comet. It looks like we have it, but it's pretty faint. So we're trying to overlap the 2 great observatories and having them help each other out, support each other. So we're working on that.
So while Casey's talking about Chandra, Casey, could you just elaborate even further? John Yang alluded to it earlier, but this was quite a multi-mission campaign.
Oh.
And Casey played a very, critical role in sort of the coordination across several NASA missions. Obviously, most of those missions are the orbiters and rovers at Mars, but Hubble wasn't the only Earth-based telescope or Earth-orbiting telescope. So it was quite a campaign, and Casey hosted a few workshops, and I'll just let him elaborate. It was, an interesting collaboration effort.
Thanks for the plug, Max. Okay, so starting with Comet ISON, NASA has helped engender a group called the CIOC, which is the Comet Investigative Observing Campaign. And what we realized was that so many different people from around the world study comets, and different kinds of people study comets. For Comet ISON last year, we needed to involve not only what I call cometeers, the usual gang of...
Oh, that is such a great term.
I'm going to just whip off the terms here. And Martians and Mercurians and Solarians and Venusians, people who actually work at the different planets and run the spacecraft at the different planets that ISON traveled by. And so we had to get them all talking to each other. And we realized that workshops, which are online if you actually want to see how scientists work and talk and discuss, and Jin Yang is part of this CIOC, and also he and Max both participated in most of the workshops. Anyway, we had to get people together last year. So we did the same thing this year for Siding Spring. The difference with Siding Spring was that while we had involved so many different spacecraft at different planets, Siding Spring was just going to be big for Mars, and was less important from the Earth, except for early on during detection and the first monitoring. Because this was really a Mars encounter, if you will, just as Jin Yang said. Again, if you had a comet that was one-third the distance of the Earth and the Moon coming to our system, everybody would be outside, everybody would be manning a telescope, and that's pretty much what we did. The really cool thing, I'm a bit of a historian too, is to think about that if we were trying to do this 20 years ago, or this comet game 20 years ago, we wouldn't have outposts at Mars. We couldn't have done this science. We could have done Hubble, we could have done maybe Chandra, but we actually have taken the first baby steps, and we actually have robotic telescopic outposts sitting around another planet. That took a picture of the comet in the sky of that planet. It's pretty cool.
I know, I've seen them, and while the rovers and the cameras on these the planet side rovers aren't ideally suited for looking up at the sky, they did manage to get a couple of pictures, so it was nice.
So I'm almost done. Well, one of the things to remember with all the Mars assets is that they're used to looking at the ground of Mars. It's the buzz phrase I use is, imagine if you took the GOES weather satellite that takes your nightly weather picture and shows you the fronts moving across the U.S. and the hurricanes coming up from the Gulf, and you turned it around and made it look at a faint galaxy or comet in the sky. It's not used to doing that. It wasn't built for that, and you have to plan and prepare it, and that's what all the Mars assets had to do, and it's pretty amazing how they worked. All right, but to back up. So cometcampaign.org, if you want to know facts about both ISON and Siding Springs, we try to put everything we know out there, what's been going on, the observing schedules. We have lots of information also from the pro-amateurs, and I'm going to talk about them in 1 second, as well as the professionals. And if you have any interest from this, also Mars JPL has a lot of Siding Springs information as well. So it's been actually really kind of fun getting everybody together and talking to a different group. It's also kind of exhausting trying to get everybody knowing who's talking to who and who knows what. I've learned a lot in the last week if people want to ask more about some of the results from various missions, and they're still coming in. But let me relate to that. The way that I found out most of what was going on during the day of the encounter, because I went outside at 2:30 in the afternoon on Sunday, and it was bright blue sky, and there was no way you could see Mars or the comet, was following the pro-amateurs. We had people at telescopes, just interested amateurs around the planet. The best seat probably on the planet was South Africa. And these guys were posting near real time on Facebook, and it was just fascinating to watch what was going on. So if you haven't seen any of their images, you should go and Google them. They're really pretty cool.
Agreed. Yep. So okay, so we have a question from Charles Bell, who's asking, how do you define the extent of the inner coma? How do you define these? Are there boundaries, things like that?
Do you want to unmute Jin Yang?
No, we don't mean with this the inner coma and outer coma. These are just like broadly defined terms. Well, actually, there's no definition about them. We just use them, as we say when we look at the very inner part of the coma, we said inner coma, and there's no boundary in it. Just nothing. We just it's just we used to talk about those. We say something in large scale out, further away, relatively further away from the nucleus. We say outer coma, but that's it.
Okay.
If you want to make a definition, the tightest ones I've heard are the inner coma is where the density of the gas coming off the nucleus is still large enough that you actually have pressure. You're in the collisional regime, we call it. And then out of that, you get molecular flow. Some other people might distinguish where you get a lot of chemistry versus where you get very little chemistry in the coma.
Okay, good.
I see here on the Q&A app real quick, I wanted just to cue in from Michael Jobin that Tony is a commentator. And
what? Look at that, a commentator. Oh, yeah, I love that.
Yeah.
I like commenteer still, too. I got to get a T-shirt that says that. So, on Twitter, we have a tweet.
Yes.
Yes, I'm going to read the tweet. It's from Vosanakis Andreas. Will NASA consider to continue funding of Siding Spring NEO survey after all that? I don't know what that is. Continue funding of Siding Spring. Is there an NEO survey on Siding Spring? Maybe it just means the NEO survey.
There's NEO surveys from Catalina, from the McNaught. There's one other one I'm blanking on. Lonios. There's a few, but I don't know whether we're paying for Siding Spring.
Okay. Of course. Yes. So, okay. Yeah, I'm not. I don't know the answer to that question either. Do you happen? Anybody else, Carol? You got any idea?
No, I don't think NASA's paying for any campaign other than the observations that are being described here.
Okay.
I mean, NEO is really to look at stuff that might come hit us. So we know it's not going to hit us. So, according to the criteria, it's not of interest.
Yeah, if it's not an object that's coming near Earth, and it's not a near Earth object.
So, next.
Yes.
Chelyabinsk is the one that got everybody motivated to keep looking for things that would hit the Earth.
Yeah, that was a wake-up call. Okay, hello.
Oh, I remember being woken up to cover that, and then the next few days afterwards, everyone's seeing things in the sky. You're all looking up.
Everybody's
exactly. I saw this thing. What was that? Everybody's.
That happens every day.
I was just impressed by all those webcams on dashboards. That was amazing.
Yeah.
So Dead Dragon Flame is saying, commenting, thank you for the explanation of the intended focal length of the rover cameras. As we pointed out, the cameras were designed for looking at bright things on the ground, not necessarily dim things up in space, but they did turn them up there and saw some stuff. So these are very versatile things. What do you think the chances are of us ever putting some kind of ground-based telescope on another planet? Make a robotic telescope designed specifically for looking. Is there any scientific usefulness to that, or is it just being on another vantage point doesn't really give us much?
Folks have talked for a long time about putting a telescope on the far side of the moon.
Yeah, the radio telescope on the far side of the moon is one thing I've really heard, mainly from my radio astronomer friends.
X-ray astronomy, UV astronomy, good. You have to remember it's going to cost a lot of money to put it there. So you have to show that it's...
Nope, because we've got printers now. We've already covered that. So.
Yeah, we did that last week. We're just going to print it out.
We solved that problem. We're going to
be using Megalith to print out.
I should have been here last week. You just solved. Great.
We did. You don't know how many mysteries of the universe get solved in these hangouts.
And I created Cold Fusion 5 minutes ago. So we are set for energy.
That's next week's hangout right there. So see?
Damn.
Well, I mean, I think people have been talking about that for years. I remember the first proposal, 15 years ago, and I think it's clear that they've fallen out of favor. That having a telescope sitting on the moon, on the far side of the moon, might initially sound like a good idea, but you have moonquakes, you have moon dust, you have who knows what else that you don't have when you're, say, yeah, so you don't. It's not the best environment to put a telescope in, whereas in orbit or at the L2 point where the James Webb Space Telescope is going to go, you don't have quakes and you don't have dust and you don't have, so there's, it's not the most ideal place to put something. Something in orbit or in a stable orbit like L2 is in a much less complicated environment in terms of a lot of those hazards.
As well, you need an additional infrastructure to get the data back.
And
something orbiting or infrastructure on the surface of the moon to transmit so that it can transmit back to Earth.
I don't think LRO would be equipped to do that. the Lunar Reconnaissance Orbiter. I don't think
We're
it's
talking about new, but don't forget, Hubble's been going for 25 years, and it's still one of the, if not the premier optical observing telescope observatory. That's a pretty impressive run.
Yeah.
Yep. That
That's
is,
basically
25 more years. Oh, no. But still.
Yeah. Go
I'm all-
2020.
I think,
Oh, that's funny.
honestly, as far as the having something on the moon, I think many things would have to be put on the place. As far as we would have to have another solid presence on the moon for a sustained period of time before we could ever think about building or landing something on there for observations. But we haven't been back to the moon, at least the United States hasn't. But you have to kind of be there for a bit to be able to do something like that. And I think there's far more interest with Mars right now than putting something on the moon. That's my personal take on it.
From I can't even pronounce this one. I'm sorry, I can't. Jacob something. It's got a lot of characters in there.
Jakub, probably Jakub.
Jakub Sjarner?
Jakub. Okay, thank you for helping me there. I'm sorry if I'm butchering the name. The nucleus of his commenting, and I got a question at the end. The nucleus of Comet Siding Spring was smaller than originally expected. I found old mass estimate of Comet Hale-Bopp nucleus, and it leads to the nucleus with size max of 10 kilometers. Is it possible that our previous estimates of nucleus sizes are overvalued?
One of the questions I have in your size max of 10 kilometers, what density was used? That the density of Comet is uncertain. A different way of putting it is that from what our results from Deep Impact and actually Comet Tempel 1, and I think hopefully from Rosetta we'll hear soon, is that comets are incredibly undense. They're mostly vacuum, 70–80% porous. So if you take that mass and you don't allow for the fact that a lot of it's empty space, you're actually going to get a smaller nucleus size than what we think we found from imaging. And the numbers I heard for Hale-Bopp were somewhere between 25 and 50 kilometers in radius. But however, on the other hand, it is true that usually we think the same way that when we first see a comet, we're not sure if it could hit anything, us, the moon, Mars. The first time you just see these things quickly, they have a very large error ellipse. Usually when we see them, we usually err on the side of how big they're bigger than eventually we whittle them down a bit. So I don't think the sense of this question is wrong.
Okay, so these almost all comets are sort of, like you say, loosely packed together, kind of fuzzy, and a lot of these things don't have well-defined properties, the boundaries of a lot of the characteristics of these comets, it sounds like. But how would you characterize the advancement of comet knowledge over, I don't know, say since Hubble's been up?
Oh, incredible. But to get back to your previous point just really quickly, imagine comets were not assembled in a factory. They're just basically the loose assemblage of dust and gas, the first things that coagulated out of what we call the protoplanetary disk, the disk material left around the proto-sun as the sun was forming, and the disk was the leftovers, the stuff that hadn't fallen into the middle of the cloud yet because it was spinning around the middle of the cloud. There was a net angular momentum. Anyway, long story short is, the same way that if you just take your hand and kind of loosely drag it through a snowbank just to kind of push together and try to make your first attempt at a snowball, that's kind of what comets are. That's why they're kind of loose and porous, and they're very weak. You stand on the surface of one, you'd probably weigh a gram or two. We think they have the strength of like meringue or talcum powder. You literally could burrow, even though they're kilometers in width, you could literally just burrow right through them. And that's also why they're not very stable. Unless they're in deep freeze, if they come anywhere near a planet or they come near the sun, they just start boiling and burbling. Their time is done. But they were, again, assembled very loosely, and it's when they came together and, instead you started piling all the snowballs together, that's when you had to make billions of these piles together. That's when they made the giant planets, and they were so massive at that point that they started collapsing each other and started changing and heating themselves up and turning into the planetary material we see today. So the comets are the raw material. So anyway, I went on a little bit. Sorry about that. So that's why they are kind of loose and fuzzy and weird and crazy. And in terms of what we've learned since Hubble went up, frankly, the Rosetta is absolutely revolutionary. We've never gone in orbit or tried to land on a comet. You're going to see incredible things in the next year from that.
Tell us about it. Tell us about that real quick.
Yeah.
And also, we've just imaged the first Oort comet from with Siding Spring. Rosetta is actually living in the environment. We haven't heard a lot from the project. They're putting together their papers now, but you've got a mission that has now, I think they're within 6 kilometers in the center of the nucleus. They're literally hovering right near it. they're feeling the dust that's coming out of this comet. If you've been looking at APOD, the astronomy pictures of the day, they have incredible images. We've only had fast flybys before. They're actually seeing flows and boulders and scarps and what looks like mass wasting and landfalls and all kinds of structures, and also sharp edges. They see craters. And overall, everybody's heard about the rubber ducky. It looks like there's two pieces that are stuck together. And one of the real questions we've had since the fast flybys was, are comets one big kind of rough snowball, as I mentioned before, that had been eaten away at the center because they've been spinning? If you took the Earth and you made it out of ice, we all know the Earth is hottest at the equator. And if you let it just spin for 4.5 billion years, you'd eventually eat away the equator and you leave the poles. So you'd kind of have two loads. The other possibility is you just kind of stuck some pieces together at the early part of the solar system, and they've been stuck together for forever. So we've been wondering about that. The rubber ducky is pretty hard to believe that it started out as a sphere and you just ate away the middle, though. So I think already Rosetta, by just getting to that comet, has revolutionized what we think of how these things are put together.
And then Bert and Ernie showed up. And there was
So the other thing, also when I was a kid, we weren't sure whether comets were flying snowbanks or whether they were actually at a solid nucleus. We've learned that they're solid and they're pretty much, the dirtiest snowball you ever threw as a kid. We're learning that, again, the Kuiper Belt and the Oort cloud were really just being found when I was young and getting into the business. Now we're sure that they're there. So that's pretty revolutionary.
Another thing is, Casey, when you were young, they had records, and some of the
what's a record
in this
anyway?
hangout might not know what a record is, but it's kind of like a CD or a DVD.
even now, CDs are. Yeah.
The other thing I would say
your analogy.
The other thing I would say that's pretty cool is it looks like we're learning more and more is that carbon dioxide looks like it's the major carbon-bearing molecule in comets, which is a little surprising. We always used to think it was carbon monoxide. And why is this important? Well, it's a more complicated molecule. People have done surveys of the galaxy and the cosmos in carbon monoxide, but nobody's looked for carbon dioxide as being the molecule everywhere that you build things out of. And there's a reason for that. You can't do it from the bottom of our atmosphere because there's CO2 in the air.
Because there's so much.
So one of the things we've learned from comets over and over again is we found the solar wind because of comet ion tails. Maybe now we're learning because of carbon dioxide in comets. It's time to go look for that all over the galaxy. Kind of cool to look, keep coming back to these dinosaur bones of solar system formation, see what they can teach us.
Yeah.
And here's that selfie of Rosetta.
Cool.
This is from APOD, as you were mentioning before. And yeah, so Rosetta's taking a selfie, and you can see the comet up there.
That's an amazing photo. I love that.
Can you get the APOD from 2 days ago? They had high-resolution images of the surface. It's just absolutely gorgeous.
Yep, I'll pull it up real quick.
Right.
Awesome.
So what you were showing us before was the lander, which is going to be ejected from the mothership, which looks like a Borg cube. Yes, I said it. On November 12th, and it's going to take about 7 or 8 hours to try and land on the surface, the head of the rubber ducky, the flat part of the head.
There's Thad Szabo again, photobombing you, Scott.
Dr. Szabo, we're getting ready for doing an eclipse outreach here at Surreal College. Getting everything prepped.
At least I don't need a shuttle mission to fix this.
He does not need a shuttle mission to fix it, but we should get one anyway.
So so I have a comment here from Dead Dragon Flame again. He's is it possible that comets don't actually outgas, but rather the movement through the ether causes an organization into plasma that actually manufactures material instead? I don't understand that question, actually.
There's no luminiferous ether.
No
That's number one.
I didn't see the ether thing in there. I don't think we. Yeah.
No, there is no ether.
No ether. All right, guys. Well, I guess I'm trying to think. Well, Scott, I know you're looking for the APOD.
I'm not seeing one from 2 days ago with that.
No, but there. I will say that on an APOD there is the nice picture of Mars and the comet a couple of days back.
Oh, we'll go with that.
You got that?
I'm pulling it up.
Yeah.
Okay.
Hold on.
Well,
many comets.
So Zolt, is there anything that you had that you wanted to show that we haven't talked about yet, or did we get to the main images that Hubble had released?
I can show the image of Mars that we got, because the one on the in that illustration is so teeny tiny that you can't really appreciate. And as someone mentioned, I think that
Beautiful.
our image of Mars is a little fuzzier than some of the earlier images of Mars that we've seen from Hubble.
Yep.
But it's not as close as it gets to us.
So those numbers in the upper left, those are the filters that were used on
those
Hubble.
are the names of the filters. There's a blue filter and a red filter that were combined to make the color image.
Is the fuzziness due to dust?
I don't know. Somebody said it was dust storms.
That's Zolt's Instagram filter that he was using.
And also, as you pointed out, it's much further away than when we take optimum pictures of Mars when it's much closer. So we have more pixels across the image. There's only 144 pixels across the image.
The reason I ask about the dust is this is the dust season, I understand, dust storm
I
season.
understood.
I was told that Opportunity actually had a dust storm to its west when it took the picture of the comet in the sky.
Oh, interesting. So, well, that could be part of the reason it looks more obscured than usual.
Now, the interesting thing about Opportunity, probably everybody's heard about it, we haven't heard anything from Curiosity yet. And Curiosity has, got the the plutonium-powered ability to look at night. And I think they were actually going into nightfall. Opportunity was coming into daylight when the observations were taken. So I'm very curious to see if they found anything. I haven't heard anything.
You said that like it was a superpower, plutonium-powered ability to look.
They're like plutonium marshmallows.
The way to think about it, if you don't, is that Opportunity has to be very careful. It gets no power at night, and it has to be very careful not to run out of power and not to get cold. So if they were taking observations when it was getting dark, they had to go get a little risky. Whereas MSL Curiosity just keeps going, just like Energizer Bunny keeps going and going and going.
Just keep going and going.
Yep.
All right, so Scott has something
Scott
up.
does have the picture, the APOD image.
Yeah, I love, because we were talking about this earlier. You're seeing just how bright Mars is compared to.
Yeah, it's very nice.
That's kind of a real image. Ours is a composite. So this does give you an appreciation.
He takes such good images.
Yeah.
Yeah, this is an outstanding example of how bright the planet is versus the comet too. So that's
It's neat. It's really beautiful.
All right. Well, I guess we'll on that note we'll close this hangout down. It's been a really interesting time. Thank you all of you it's great seeing a lot of you again. Zolt, Max, and John Yang. It was good to see you, and Carrie. It was awesome to meet you. So I'm glad to have you here. I hope you'll come back and tell us what you've learned after you've had a chance to go through some more of these data.
Anytime.
Awesome. Okay. Well, thank you guys very much. Next week, speaking of Hubble's 25th anniversary celebration, will be in the first of our actual Hubble 25th themed hangouts we'll be having. It's called the History of the Hubble Space Telescope. We're not going to cover the entire history on that one hangout, but we are going to have some guests and panelists who are very familiar with the early days of Hubble and throughout its whole mission. So we're going to talk about that next week. We hope you guys will make it on a Thursday at 3 o'clock. Until then, thank you all for all your great comments and questions. We really appreciated it.
Yeah, and if you guys want to see the eclipse, join me in an hour with Know the Cosmos. We will be doing a free live webcast of the eclipse, not only through a white light filter, but through a hydrogen alpha filter here in Los Angeles. So stay tuned for that, because not
that's one of those. You said you had a Coronado telescope set up. One of those.
Yep, we have a Coronado PST that will be.
Those are outstanding. Those are outstanding. I have one myself. So very good. Okay, so you have your event and everything already set up.
Yep, it's all set up. It's on Twitter, on Google Plus, and Facebook. So
I'm going to be watching because I can't see it from here very well.
So on the East Coast.
Right. So
West Side represent.
It will be sunny as it's in the
Okay. Well, thanks everybody for watching.
Okay, thank you so much, our guests. Thank you so much. That was fantastic. I'm glad you got the images.
Yep, it was great having you back. Thanks for all your work, and thanks for joining us. Until next time, keep looking up. Yeah. Remember him from the Planetary Science Institute. He was around our hangouts when we were talking about Comet Ison. Hi, John Yang. Welcome back. Also, Max Mutchler of the Institute and Zolt LeVay, also of the Institute, helped us put together all of these images, so that we're seeing today. And Zolt, do you know you got a fan club? Yeah, when I told people about this event, we got some comments on Twitter about, oh, Zolt's going to be there, so I have to go. So
Cool.
you got a fan club. You're like famous now.
So
So
hope I can live up to the hype.
I think you can.
okay, so before we get going too far into the Hangout, let me remind you that you can tweet at us using the Twitter with the Hubble hashtag or the Hubble Hangout hashtag. We're also looking at the Q&A app on YouTube and G+, as well as the comment section on both of those pages. So we hope you'll comment, ask questions. All of these guys are here ready to take your comments and questions for you, so we hope you will do it. Yesterday, we talked about this a little bit with Frank, and Frank Summers, and he was telling me that, well, that these images were a little slow in coming, right? I mean, that we were a little bit, Hubble looked at the flyby, but because of something called I think it's the SIC, this gets the award for the worst acronym ever. It's called SIC and DP module on Hubble, which I guess is this thing that Hubble does this thing I did not know, where it kind of does this equivalent of a intrepidmuseum.org. They'll learn about they have tickets available for events and stuff that are coming up. So I would encourage you, if you're in the area, to check it out. Hubble at 25. That's our new exhibit, and we've posted about it on Facebook and Twitter and stuff like that. And I'm about to do it on G+ after this event. So I'll give you more information as that progresses. Carol and Scott, Dr. Carol Christian and Scott Internet, the driver of the Lewis. Oh wait, I did not say that right, did I? That is not right. Well,
I have a sonic screwdriver.
Scott Internet's a pretty cool name, though. Anyway, Scott will be Scott Lewis is helping drive the internet in this hangout, as is Dr. Carol Christian. She is the Hubble outreach scientist for the Space Telescope Science Institute. So today we're going to, like I talked about, Hubble on Sunday looked at a rather unusual close flyby of a comet to the planet Mars. It went within 140,000 kilometers, and which is about 80-something thousand miles, I believe, which is really close, really close. And so Hubble went and looked at it. And we took some images, and with us to talk about this today are the various astronomers and people who helped get these images together. Carrie, is it Lissa? Liss, sorry, thank you. From Johns Hopkins, he's an astronomer and comet person. Also, Zhanyang Li, you might remember. Hello, everybody. Welcome to today's Hubble Hangout. My name is Tony Darnell, and we have, I think, a really interesting topic today. Now, you guys have been around Hubble Hangouts long enough to know that Hubble has been over our heads for almost 55 years, circling overhead, looking at things, showing us stuff. And today, and this last Sunday was no exception. Hubble looked at something, and it showed us stuff, specifically a comet that passed close by Mars. And today we're going to be talking about that with the old gang of a lot of very familiar faces and a couple of new ones. But before I get to that, I want to make a quick announcement. Today, as I said a while ago, almost 25 years Hubble's been up in space. And you're going to start to see a lot more about this from us. We're going to be talking about it a lot more. But all these events that are going to be coming up for Hubble's 25th anniversary, which will be in April. The first of those things is starting today. So if you are in New York City, the Big Apple, you need to get your little booties over to the Intrepid Museum. And they have opened up a Hubble at 25 exhibit. It opens today, and it's going to be going on at least through April. I know that much because one of the events they have planned, I'm going to be there for. So you've got plenty of time, but get over there today if you have a chance. Go to the website if you want to learn more about it. Is
investigators involved in this campaign that was more affected. But fortunately for the bulk of this campaign, the timing was not too bad. It could have been much worse if it had landed right in the middle of our campaign.
Yeah. Now, I guess, I wanted to bring that up just a little to kind of give people a little of a behind-the-scenes thing of what it's like to use the Hubble and some of the things the Hubble goes through. And I just learned about that recently, so I thought I'd mention it. It's not a serious thing that happens, but we just have to wait for it to pass, I suppose. So, okay, Jianyang, let's talk about the. I'd like to ask you about this flyby. What can you give us an intro into what happened? What went on last weekend?
Well, as you said, basically the comet is coming from far, far away, like the edge of the solar system, and then it happens that it just fly by plasmas from very close distance. The distance is actually only a third of the distance between the Earth and the Moon, so it's very close. Imagine if you have that kind of comet that fly by the Earth from that distance, that's going to be amazing. But this time it happened on Mars, and basically the comet, if we imagine the geometry. The comet basically comes from the bottom, from the south, below the plane that the Mars is orbiting the sun, and then from the bottom, and it passes. I think it's slightly inside Mars orbit, and then cross Mars orbit plane to above, and then from there it continues to go to its closest point to the sun, which is very close to Mars too, and then leave the solar system. So what happened last?
Spinning beach ball, where this is a known thing it does, and you just kind of have to wait for it to get done. And
was that a Mac reference?
Yeah. Well, that's the way it was described to me. I guess the Hubble does this every once in a while. And this is an inside, behind-the-scenes look, guys. We got these emails earlier in the week. Hubble's fine now, but apparently it does this thing where it just kind of does a spinning beach ball kind of thing. And just like it's one of those things where if you get it on an Apple computer, it's just you just have to wait for it to finish, and then everything's fine supposedly. So
on a Windows computer, you get the blue screen of death, and sorry.
And that is a bigger problem. Yes. So I guess these images were a little late coming down. Isn't that right, Zolt?
I think maybe Max can answer that a little bit better. Our images that we had came down in good time.
Yeah, they came down over the weekend. There was a sequence that started, I guess, late on Saturday, through Sunday and Monday. That was all before the failure that you mentioned. So those data came down. There was a little problem getting them out of the archive, so we didn't really get to look at them until Monday morning, even though the closest approach had already occurred. That was really the first chance we had to really dive into the data. And then it was, I think, a good day and a half later that there was the real significant, SIC and DH event, which caused a bigger hiccup. So thankfully, most of the data from this campaign was already in hand before that. There was a continuing program by John Clark, one of the investigators